The other massive thing we have been doing is our work with OpenAI. We have trained the GPT family of models for human-like language generation, DALL-E for realistic image generation and editing, and Codex for code generation in more than a dozen programming languages. But it's not enough to talk about these models. It's all about applying them and turning these breakthroughs into capabilities for you, which is why I'm so excited to have the OpenAI co-founder and CEO, Sam Altman, with me here today. Hi, Sam.
Hey, Satya.
Welcome.
Thank you.
You know, Sam, we've been working together now for a year or over a year. In fact, I think last time at Ignite is when we first announced Azure OpenAI Service right here. And the state-of-the-art models like GPT-3 and Codex coming together with the enterprise capabilities of Azure have been a real game changer. It's exciting to see so many customers from HSBC and PwC to Shell and Wipro are already applying these models in pretty advanced scenarios like content creation, code generation. And I was wondering, Sam, if you could share some of the commercial scenarios that you've seen and are excited by.
Yeah, thanks, Satya. We're really excited about the wide range of uses that customers are finding for these AI systems. Of course, a lot of companies are using our completions endpoint to help create really compelling content, from web copy to recruiting materials. And recently, we've seen more sophisticated applications that combine multiple AI capabilities for some really interesting use cases. For example, a number of Fortune 500 companies are now using a combination of our embeddings and completions endpoint together to drive powerful search features that significantly improve current processes. Compliance teams can use these capabilities to search complicated external standards documentation and then compare them to their own internal policies. And if they find any gaps, they can even use these capabilities to suggest new language. This is a type of application that cuts time spent from manually comparing documents from many weeks down to hours. Customers are also using that combination of embeddings and completions to help employees quickly find and synthesize answers from across a massive internal knowledge base. For example, Morgan Stanley is building an AI assistant that helps their tens of thousands of wealth managers better support their clients. The assistant combines search and content creation so that wealth managers can quickly find and tailor the right information for every client at any moment. It's using advanced AI technology to deliver deep knowledge.
No, that's so right, Sam. And even that thing about content creation and search both being supported by AI is just fantastic. And today, obviously, we are very thrilled to put even more of these breakthroughs in the hands of customers. We're bringing the power of DALL-E to Azure OpenAI Service. And we want all our customers to be able to apply DALL-E to any commercial use case, whether that's image editing and generation or content personalization and rapid response marketing campaigns. And in fact, we're already seeing some fantastic use cases. For example, RTL, the largest media company in Germany, will create personalized imagery for audiobook and podcast listeners as part of their subscription service. And Mattel has been exploring using the service to spark creativity across the entire organization, from toy design to marketing. And so with all that, Sam, what's there as next frontier for OpenAI in terms of innovation?
It's an exciting time. We take our role as responsible stewards of this technology very seriously, and I know you do too. So we're very excited to collaborate with Microsoft to set the standards for deployments and use of these powerful AI systems across the industry. A critical part of making sure our systems are as safe and as aligned as possible is learning from real-world use. And so our approach is to iteratively deploy our technology as responsibly as we can, learn at each stage, and feed those learnings back into the system to make it safer. We're also working to make our AI systems smarter, more capable, and more useful. We recently open-sourced our automatic speech recognition system, Whisper, which can transcribe complex speech more accurately than ever before, like complicated technical terms and accents.
That's so cool. And I know you're also working on something else that's pretty exciting. You want to share that with us?
Yeah, we're so excited to show you how OpenAI is making our Codex models interactive, bringing them one step closer to becoming a real pair programmer. I'd love to show you a little bit of what we're working on. Our latest Codex prototype can explain and debug its own code, learn from mistakes, and make corrections on the fly. Recently, I saw just how powerful this tool could be in a programmer's workflow when I gave Codex a problem I saw discussed online. Let me show you. So first, we asked Codex to calculate the probability that in a single elimination tournament of 8 players, the second best player finishes in second place. This is assuming that the better players always defeat the weaker players in each round. I'm going to ask Codex to solve the problem using a simulation, and we'll see it take my direction and turn it into code. To start, you can see that Codex suggests and then imports the random library to generate pseudo-random numbers. For its next steps, Codex explains its approach in natural language with detailed comments, creating a list of skills of the 8 players and outlining a tournament bracket. For each step, Codex generates and executes the code, and then evaluates its results before moving forward. Now, Codex is writing the tournament's second and final rounds. Codex then checks if this result proves or disproves the initial problem. In this one random tournament, the player who lost in the final match was not the second most skilled player. To estimate the average probability after many games, Codex invokes its simulated tournament 1 million times in a loop. As Codex reasons through this problem, it's explaining each step in natural language. And here it looks like Codex has a slight bug. It's estimated the probability will come out to 0, very unlikely. Codex reviews its code at each step in all real time, so let's watch what Codex does here. The model correctly notices and identifies the issue. Now let's see how Codex manages to resolve it. Even though Codex identified the issue, it still didn't correctly fix it on the first try. With the new condition, the probability is now calculated at 100% instead of 0, still very likely wrong. So it tries again, and now it's going to get it right. Here we see the power of this new model. It evaluates its code, recognizes its own mistakes, and attempts to fix them. With only the problem statement and my single brief instruction, Codex independently solved the entire problem. I'm excited for how this technology will dramatically improve the productivity of software developers, bringing Codex one step closer to becoming a real pair programmer.
Thank you so much, Sam. It's just a real pleasure to be working with you and your team. I'm really excited about the work we're doing together and all the advances to come.
Thank you, Satya.
Thank you.